Okay, so Leetcode practice time. So in this video there are two goals. The first goal is to see how to solve this problem. We are going to find the solution and also then do some coding work. And the second goal is to see how we should behave in a real interview. So let's get started. So remember, in a real interview, the first step is always try to first fully understand the problem. If there is anything unclear, please bring up the question, and at the same time think about some edge cases. So let's take a look. So search in rotated sorted array. So you're given an integer array, nums sorted in ascending order, with distinct values, and an integer target. So suppose that nums is rotated at some pivot unknown to you beforehand. Like this, 0, 1, 2, 4, 5, 6, 7 might become something like this. So if the target is found in the array, return its index, otherwise return -1. So let's see. For this one, we are going to return 4. Of course, for this example 2, we are going to return -1. It makes sense. Let's see some constraints. So it said that the length of the nums array is between 1 to 5,000, and each number is between -10k to 10k, and all the values of the nums are unique. So nums is guaranteed to be rotated at some pivot. Okay, so how to solve this problem? So if it is not rotated, of course we should use binary search. But since it is rotated, we may need to tweak the binary search a bit to make sure that it fits with the new situation. So overall, I don't think there's any edge case at this moment. So let's just think about how to tweak the traditional binary search to solve this new problem. So remember, for binary search, we have the start pointer, the end pointer, and the mid pointer. Like every time we try to minimize the searching scope by half. So let's see, for this one, I think in addition to compare the pivot with the target, we have another thing. So let's say, for example, let's say 0, 1, 2, 3, 4, 5, 6, and 7, and we rotate it to be something like this. So first of all, we have let's say we have the start point here, and we have the end point here, and we have the pivot, which is there. So there are 8 numbers. Let me give you another thing. So 7, 8. So this is a pivot. So pivot is going to be here, which is the middle. So the mid pointer. So suppose the mid pointer, which is a pivot, it falls within it falls before the rotation point. If it falls before the rotation point, and if we compare the target, so the condition is like, if the pivot point falls before the rotation point. So there are two conditions. So if the target is between, let's say the pivot is actually just nums m. If the target falls between nums s and nums m, then we are going to search between s and m. Otherwise, it means that it is either smaller than the start, than 3, or it is larger than mid. Then we are going to search between m and made and E. So otherwise, there is another situation. So for example, let's say we change this a little bit. Let's say that the rotated array is something like this. So the pivot point actually falls after the transition point, or after or on the transition point. So what we would do is we will try to see if the target is between nums m and nums e, then we are going to search between m and e. Otherwise, it means it is either larger than nums m, either smaller than nums m or larger than nums e. Then we are going to search between. Otherwise, we are going to search between s and m. So that's pretty much about the condition, how we change the traditional binary search to fit the new situation. And the runtime is still going to be log n and is length of the input array. So let's get started and do some coding work. So for coding, we care about the correctness and the readability, and of course we care about the speed. So don't be too slow. Let's give it a shot. So first of all, we will need to define the start as 0 and as equal to nums.length minus 1. So similar as the binary search, well, start is smaller than the end or equal to the end. So we are going to say int made is equal to start plus end minus start divided by 2. So so if it is so like we said, first of all we need to tell whether the m is before the transition point or before the rotation point or after the rotation point. The thing is, we just need to see if the nums made, if it is larger than nums start, then it is actually before the transition point. So we are going to say if so actually we should just say if nums mid is equal to the target, then we are just going to return mid, which is the index. So if nums mid is larger than nums start, it's happening before the transition point. So we are going to say if target is larger or equal to nums start and target is smaller or equal to nums.n, then it is for us to search within S and M. So we are going to say the n is equal to made. Otherwise, we are going to set, so if it is smaller than the start, or if it is larger than the start, larger than the end, then we are going to set start as made plus 1. So that is that. Otherwise, this is else branch. We say the target is between nums m and e. So if it is after the transition point, we would say if the target is larger than nums made and target is smaller or equal to nums n, then we are going to say okay, start would be made plus 1. Otherwise, we will have the n as equal to made. So let's see. Yeah, so let's see. Should we just have this as made and as made minus 1? Because if we already have the made as target, then we actually, yeah, I think it's okay to have n as made minus 1. Okay, okay, so target is smaller than, sorry, this should be, should be smaller than the made here. It should be smaller, larger or equal to start and smaller than made, and this should be larger than made and smaller than or equal to the n. Okay, and finally we are going to return minus 1 here. Remember, after you're done with coding, it's time for you to do some testing. So let's take a look at this this piece of code by going through this example, which is this. So let's say we have the task case as input array as this and target as 0. So first of all, we have the start, and we have the end pointer, and we have 0, 1, 2, 3, 4, 5, 6. 6 minus 0 divided by 2 is 3. 0 plus 3, 0, 1, 2, 3. So the made is pointing to 7. So we see that it is, because nums made is larger than the start, so it is before the transition point, and we see that 0 is actually smaller than the start number, so we are going to have the start as made plus 1. And then we set the made to be here, and we see that the made is happening. So for this subarray, the made is happening. It's happening. It doesn't have a transition point for this subarray actually. So the made is happening after the. It's happening before the transition point, which is this one. So we are going to say okay. Target is so 0 is within start and made. So we are going to say okay, n is equal to made plus 1. So next time we set that made is equal to 0, so we are going to return the made. Alright, so I think that should do it. Let's see this one, if the number doesn't exist. See this one maybe. Let's say the number doesn't exist. So we have the start, we have the made here, and we have the end here. So it is that the made happens before the transition point, so it falls within this if branch. So we are going to set n as made minus 1. Okay, so we are going to see the target is actually smaller than made, so we are going to actually set start as made plus 1, so which is here. And then next time made is here, pointing to 1, we see that in this subarray there is no transition point, so we are going to fall within this if branch as well. We see that 3 is larger than the end. So if 3 is larger than, it's not within the made. So it's not within start and made. So we are going to have start as made plus 1, which is here. And next time we see that made is not equal, so 2 is not equal to 3, and we are searching within this 2. So we see in this, and we set made as this one, and because made is equal to the start, so we are going to fall into this else branch. So we are saying that okay, target is larger than the made, so we are going to set start to be made plus 1. So it's something like this, and finally we run out of this while loop and return -1. So I think it works for that input case as well. Let's give it a shot. Alright, so let's do a submission. Alright, it says wrong answer. Why it is wrong answer? So let's run this test case. So if we have 3 and 1, and we are searching for 1, so we have the start, and we have the end, and we also have okay, so if it is, so we have the start, we have the end, and the made is actually this is a made at the very beginning. We see that the made is, if made is larger than the start, then we see that it happens before the transition point. So let's say if it is larger or equal, I think that if it's larger or equal, then we see that it doesn't happen. So if larger or equal, it is happen before the rotation point or the transition point. So target, so here we see that target, which is 1, it is actually smaller than the target, so we are going to set start as made plus 1. So next time we should get the answer. So I think this should be able to solve this problem. So let's see. So let's run this code. Alright, so let's give it another try. Okay, so now everything looks good. So it is a transition point definition. So if it is larger or equal, then we define it that it happens, the made happens before the transition point. So that was an edge case, which is the made is actually at the transition point, how we define it. So that's it for this coding question and the puzzle. And if you have any question about the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.